We're going to go back to our overview of the guide. Like Justin outlined, we have 7 chapters, and Justin and I are going to explain in a little bit more detail over the next 15 to 20 minutes exactly what we included in each of those chapters, how they link together, and how the information in those chapters can be practically used in the development of emission inventories and evaluating policies and measures, undertaking health impact assessments, etc. So in chapter 2, the aims and goals of the guide is to provide practical approaches to integrate air pollutants and short-lived climate pollutants, specifically in terms of emission inventories, fundamental to tracking progress on emission levels in different sectors, on assessing the impact of different policies and measures to understand how a particular climate change target could be achieved and what benefits that could have for air pollution, in understanding how an air quality management plan could benefit greenhouse gases, for example. How do we evaluate the specific policies and measures? And then on quantifying the health benefits, so outlining a health impact assessment methodology. I wanted to include this here to really specify the pollutants that we're talking about when we cover the 3 categories of pollutants. When we talk about air pollutants, we're talking about the sometimes called criteria air pollutants, or those that are defined by air pollutants by the World Health Organization. Particulate matter like PM 2.5 has the largest impact on human health, but there are a range of other pollutants that contribute: nitrogen oxides, volatile organic compounds, sulfur dioxide, ammonia, etc. On the greenhouse gas side, I'm sure everyone is familiar with the list of greenhouse gases that are covered, for example, in the IPCC greenhouse gas emission inventory guidelines. In the center, we then have short-lived climate pollutants, which contribute to both issues, contribute to air pollution and contribute to climate change. Black carbon that we mentioned is a component of particulate matter that has a large impact on human health. Tropospheric ozone is a short-lived climate pollutant that is not directly emitted. We don't emit ozone, but is formed in the atmosphere when nitrogen oxides, VOCs, carbon monoxide, and methane react together to form this greenhouse gas, ozone, that is also an air pollutant that has large impacts on our respiratory system when we breathe it in. Methane is a greenhouse gas, but it only stays in the atmosphere for about 15 years, so it's short-lived, and it contributes to the formation of tropospheric ozone. So when we're talking about integrating air pollutants, short-lived climate pollutants, and greenhouse gases, it is about understanding the common sources of the list of pollutants that are on the screen here, and understanding how a particular policy or measure could lead to the reduction in the full suite of pollutants that we see here, and understanding what impact that reduction on those pollutants could have on human health. And so the first step in integrating greenhouse gases, short-lived climate pollutants, and air pollutants together is often the development of an integrated emission inventory. And Justin is going to talk about how the information in the guide helps us to understand how that can be achieved.
Thank you, Chris. And I think the fundamentals of an inventory are really about understanding the sources or removals of atmospheric gases concentrations. So, I mean, very carefully, I choose language about greenhouse gases around minimizing the concentration of these gases in the atmosphere. So that includes increasing the removals and reducing the emissions, which is exactly the same as what we're trying to do with air pollutants. We're trying to minimize the concentrations of toxic or ozone-forming air pollutants in the atmosphere. And how do we understand how that happens? We understand a relationship between what we're seeing coming into the atmosphere and activities, and anthropogenic activities. And those could be transport related, agriculture related, They could be related to use of air conditioning, use of certain toxic materials in industry. So the inventory really starts to work backwards into understanding the problem and understanding the sources or the removals of these gases, these pollutants in the atmosphere. So when we boil down the activity of inventories, we're collecting activity data. We're collecting data that allows us to understand the magnitude or the potential magnitude of a source of emission or a removal. And many of these are very common. So an integrated inventory is an extremely important starting point. The difficulty with integrated inventories is that we tend to find them being established through the regimes that are focused on particular issues, particular problems. So air pollutants will be dealt with in maybe a different department, a different regime, a different agency to greenhouse gases, because the problem has been identified and being followed up through these different regimes. So the key to integrating is to get a common data set of activity data brought together to remove the overlap and improve efficiencies and strengthen the capacity. So you could have two teams of 5 people, one team working on air pollution, one team working on greenhouse gases, combined to a new combined team of 10 people with improved efficiencies and better data gathering, better strengths, better connections, better networks. So this is important, as well as important is the need for consistency in the outputs from these two activities, because effectively you're describing activities. And if you use different assumptions, different data sources, and you're describing the same activity, whether that's road transport or whether that's agricultural livestock, you end up confusing the stakeholders who are trying to make decisions. So that brings consistency by integrating the inventory work. The methods can be complementary. In many cases, you have more detailed analysis for some sectors. Sometimes you use a different approach because you need to understand more detail in those sectors. For example, in road transport for N2O and methane, the benefits you get from those higher tier calculations are benefits given to you by the need to understand road transport NOx emissions, NOx and VOC and PM emissions. So you get some complementarity, you get some improved material that you can use to verify your data from either side. You have a one-stop shop team for advice and consistent approaches and managing QA/QC, who are now all working together. However, to start with, you do have to deal with more complexity and more demands and more paymasters. Next slide, please. This is just an example really of the flow of information, and I appreciate people can't see it very well, but it's one of the figures in the report. I'd like to draw your attention to the two merged sort of tan colored bubbles on the far left hand side. This is the point here of the activity data, and this is a huge area of overlap, huge area of opportunity to improve the integration. You get more detail for air pollution, usually spatial detail, which you can also use to encourage subnational stakeholders on greenhouse gas emission reduction. But a combined effort to collect this activity data is the important focus. And as you can see, the top section with the green boxes moving towards the top right-hand side is what needs to happen to the data in order to be able to have a good view on health and health analysis. So you can see that data has to go through a lot of rigor, has to go through a lot of additional analysis, needs new information added to it in order for it to be useful. Whereas the greenhouse gas inventory has a pretty short pathway towards the greenhouse gas reporting. So the greenhouse gas inventories can benefit from that extra rigor, those extra specialists looking at the data that are happening in all that processing above, but also the air pollutant specialists and experts can benefit from having the greenhouse gas inventory approach applied, which is more of a top-down, more of a mass balance and understanding of completeness applied. So there are a lot of synergies. Next slide, please. In terms of the focus for the guide, we look at understanding the main point is understanding what extra is needed to add on to a greenhouse gas inventory to help to start providing useful information around air pollutants. And this might be to the air pollutant health community, but it might also be in order to express to stakeholders the co-benefits of greenhouse gas emission reductions or removals. So what extra is needed? What do we need to do to fortify that greenhouse gas inventory to make it much more valuable for a wider set of stakeholders? We tend to assume that the greenhouse gas inventory is available in some form, some kind of statistical analysis of energy balance of agriculture, livestock, crops, and forest. And we can build on that, and we can start to expand those components. So it's an enhanced greenhouse gas inventory, but it's also something that starts to play to national and subnational air pollution understanding and improvement. The sectors we've covered are energy, and this is particularly looking at the conflicts and issues that need to be understood around transport, biomass, so transport diesel vehicles, as Chris mentioned. Catalytic converters have got some challenges associated with them in vehicles, so if you're trying to clean up the city, you may also be increasing emissions of greenhouse gases. And the whole question about biomass and biomass burning, which is much even broader than air pollution and climate. It's to do with land and land demand and water. But these issues become much clearer if you start to present them in an integrated inventory, because you can play some tunes on your policies and measures to increase biomass, and suddenly you start to see challenges for air pollution. On the industrial processes and product use, we can see the air pollution improving the integration of plant-specific data. They need that for the spatial resolution. There's effort that goes into understanding those individual tier 3 effectively calculations. And if that extra effort and that extra analysis can be integrated into the greenhouse gas inventory, you get a benefit for the greenhouse gas inventory. Plus, you get a benefit from the greenhouse gas inventory by understanding for those plant-specific sources what is accounted for under greenhouse gas accounting regimes and what isn't. So all the biomass, the biofuel use. You can also have a lot of policy questions about the types of the types of practice in industrial processes, and sometimes you change the practice to benefit the climate, but you have a negative impact on air pollution. AFLU, which is agriculture, forestry, and land use change. With integrating the air pollutants and greenhouse gases, you get more resource put into understanding the nitrogen balance. So you're looking at ammonia and N2O within that regime rather than just one or the other. Huge opportunity for confusion and inconsistency if you do them separately. And in terms of forest and biomass and understanding biomass burning and what sectors it's burnt in or where it goes, there's resource from the greenhouse gas inventory that could benefit an understanding of how wood fuel is burned in the air pollution inventories. And finally, on waste, air pollutant inventories have a much higher interest in the combustion of waste, the burning of waste, because the pollution it causes. And that activity can help to enhance and improve the greenhouse gas inventory. So in the guide and in these sections, in this chapter, we look really at these areas where it makes sense to integrate, where there are opportunities of integration, how integration can happen, and also the challenges, the warning signs, the things to get in place early on to make sure that that integration doesn't fall apart because there are two different camps demanding different information. I'll hand back over to you, Chris, for the other chapters.
Thanks very much, Justin. So once we've got our emission inventory, once we've read through the chapter that Justin described and we've managed to integrate our emission inventory of short-lived climate pollutants, air pollutants, and greenhouse gases, one of the next steps, both in climate change planning and air quality management, is then understanding how we can evaluate policies and measures. And so the next chapter of the guide aims to outline the key considerations for integrating policy and mitigation measure analysis for greenhouse gases and air pollutants. And there's three key things that it emphasizes. The first is that scenarios or projections are the fundamental tool to undertake that policy analysis. And that's common to both greenhouse gases and air quality management, creating future scenarios that represent a baseline without implementing any measures, representing policies and measures that are included in existing plans, and understanding the potential of additional actions to reduce greenhouse gases or air pollutants is a common way in which both greenhouse gases and air pollutant analyses have been undertaken. Integrating them together is relatively straightforward, and many of the considerations that Justin outlined for integrating inventories are common to integrating analysis of policies and measures. So if, for example, if you're listening to this presentation and have undertaken a greenhouse gas mitigation assessment, it is relatively straightforward in the same way that air pollutants can be added to a greenhouse gas emission inventory. The same process of adding emission factors, whether they are have been locally measured or from international guidance, integrating those air pollutant emission factors into the greenhouse gas mitigation assessment is the first and most important process for developing an integrated analysis of greenhouse gases and of air pollutants. The second part of this chapter emphasizes one of the key considerations when you make that integration, and it's the methodology that is chosen to evaluate specific policies and measures. When we expand our analysis from greenhouse gases to short-lived climate pollutants and air pollutants, we may also be expanding our range of policies and measures that we want to analyze in our assessment or in our tool. And as we expand those range of policies and measures, it may be that different methodologies are more appropriate or provide more insight into how we could mitigate a particular pollutants from a particular policy and measure. This example here is for the transport sector. And when we look at the particular interventions that we may have in the transport sector, whether it's adding biofuels to our fuel mix, whether it's increasing the share of electric vehicles, whether it's emphasizing fuel efficiency in internal combustion engines, or vehicle emission standards like Euro 4, Euro 6, or behavior change, shifting from using private vehicles to active travel or public transport. The specific policies and measures determine to some extent the methodology that is necessary to be able to robustly evaluate them. So if in integrating our assessment of greenhouse gases and air pollutants, we suddenly need to add into our analysis the introduction of vehicle emission standards, then that requires that within our analysis of the vehicle fleet and understanding the emissions, we are breaking down that vehicle fleet by emission standard so that we can look at shifting from Euro 3 to Euro 6, for example. So there's a lot in terms of the considerations of the methodologies that are needed to evaluate policies and measures. And finally, we go through common policies and measures that are used in the evaluation for greenhouse gas evaluation and for air quality management and identify where the major synergies are. So as well as the methodological guidance on how to undertake policy assessments in an integrated way, we also get to the specifics of particular interventions and where there is likely to be synergies or possibly trade-offs between implementing that policy for climate change and for air pollutants. The next chapter then focuses on moving down the chain from emission inventories, evaluating policies and measures in terms of emission reductions, to a methodology, a step-by-step guide on how to quantify the health impacts of particular policies and measures in terms of the reduction in air pollutants. And I should say that this chapter was written by Dr. Susan Annenberg from George Washington University. And the first point to emphasize is that the methodology that's put forward for the assessing the reduction in the health benefits from air pollutants is framed in the context of the wider range of health benefits that are possible from climate change and air pollution interventions. Air pollution reductions are a subset of the health risks that can be reduced from taking action on climate change. And so the methodology that's put forward here is presented in terms of how health benefits of air pollutants can be reduced, but is equally applicable to any other health risk that is changed as a result of a climate change or air quality intervention. As we mentioned in answering your questions earlier, we outlined a step-by-step guide of how to go to those emissions, spatially distribute them, understand how they change concentrations and exposure, and how that change in exposure then impacts human health in terms of premature mortality, morbidity outcomes. Finally, on the health impact assessment, we highlight tools that can be useful in actually applying the health impact assessment methodology. Our guide is just a document that highlights.
We just have to wrap up in the next few minutes, so thank you.
Okay. The guide is just a document, but these tools can actually apply this guidance. And I think I'll give the last word to Justin to highlight some of the key messages on the chapter, focusing not on the data, but on actually how you put this into practice.
Okay, I'm just going to sum up with a few very quick points. So integrating will strengthen the teams if you can get over the regime differences. And we have to point out that when we integrate air pollutant greenhouse gas activities, we're really looking at integrating multi-organizational virtual teams of people working together. So integrating this can help strengthen these teams. I don't think it will undermine those teams. We need to work out the spatial scale and the benefits for the air pollutant fraternity of integrating with the greenhouse gas inventories. But when we do, we get a much wider base of stakeholders that value this combined integrated system, will help resource and improve the quality of the data in it. And finally, on the last slide, this section introduces a number of different steps, and you can see the timeline, at least 10 years of evolution and development. So start that process soon, understand the investment that you need, or recognize that you need investment in this in order to get the benefit of efficiency afterwards. We need agreement to integrate between organizations. Those organizations need to understand the benefit to them from changing from what they do at the moment, if they already do something. We need to understand the organizational structure that we're going to hope to end up with. We need to make sure we understand the outputs and the data sets needed to make that system valuable. And underpinning all of this is a continual and continuously evolving improvement plan. So start noting down things that you'd like to achieve, things you'd like to produce, and then start thinking about how to get them. These 9 steps cover the process of starting to build the institutional arrangements and MRV system, and we'll be very happy to answer any questions around those now or anytime after this webinar.